All right, we're gonna. I said I was gonna try to finish review of this test, so let's give it a shot. I think we left off at number. Well, we didn't do number 9, but I'm just gonna do it right now just to show you. We just kind of talked about it briefly. Let's just do it really quick. This should be a pretty simple one to do. All right, this is number 9. So first thing we do is subtract a 1 from both sides. That 1 cancels out. Bring down the 2x. 13 minus 1 is 12. Divide by 2. X is 6. Pretty simple. That's the easiest one of all of those for sure. All right, 10's not a whole lot harder, but then it gets a little bit trickier. Not much, but a little bit. So this is going to be 3 times x minus 4 in parentheses equals negative 36. So what we're going to do is we're going to distribute that 3. Now, if you wanted to, you could actually divide both sides by 3 if you wanted to, just to make it a little easier. That'd be okay. But you probably look at this and probably your first instinct was probably to not factor out, but to distribute the 3. So let's go ahead and do it that way. So I've got 3x minus 12, because it's 3 times negative 4 is negative 12, equals negative 36. I'm going to add a 12 to both sides, add a 12 to this side. That cancels out, bring down the 3x. And this is what, negative 24? All right, divide both sides by 3, and x is negative. Don't leave it like this. Some of you left it like this on the test, and I marked it wrong. And I'm going to mark it wrong when you take the test tomorrow. If you don't reduce your fractions, make sure you reduce your fractions, and that's negative 8. That's the only acceptable answer right there. X is negative 8. That's the only thing I'll accept. All right, number 11. If I go too fast, you could always go back, pause it, watch it again. What I would suggest is that you watch this for the first time and then go back and try the problems on your own, especially if you got it wrong when you took the test the first time. Here's the one I was talking about in class today, a little earlier. I'm actually teaching. You can come in here if you want. I'm recording. Say hi, Mr. Cheadle.
Sorry.
Say hi.
How you doing?
You got to speak louder than that.
Oh, hello.
There we go. All right. I told the seniors that I would finish up this review we didn't quite get to.
Oh, my bad. All right, I'll let you finish that. I'll talk to you.
Feel free to stay if you want. Okay. All right, so we're going to distribute the 2 through both of these. So that's 2x minus 10. Here's the part that a lot of people got messed up, and we talked about this earlier today. So a lot of you got this part right. You said minus 3x, but some of you, not all of you, but some of you forgot to distribute that through the whole entire thing, because it's like a negative 1 out in front. That's basically what it is. So negative 1 times 3x is negative 3x, and here's where you went wrong, some of you. Negative 1 times positive 1, and that's a negative 1. Some of you put a plus 1 right there. You forgot to distribute the negative. All right, let's keep going. I got 2x minus 3x, which is negative x, and then negative 10 minus 1, which is negative 11. And that equals 0. You could do this a couple ways. If you want to keep the x positive, just move the x over here, and then you're done, basically. So I'm going to add an x. I'm going to add an x. That cancels out. I got a negative 11 equals positive x. 0 plus x is x. That's your answer. You can keep it like that. If it was me, though, I'd probably write it like this. And that looks pretty good right there. Excuse me. Getting a little sore throat. Hope it's nothing bad. All right, number 12. Same kind of thing, but it's a little bit more involved. Did I do this in class? I might have done this already in the other lesson, but I'll do it again. I got a few minutes. I do have to leave pretty soon, though. I have a chiropractor appointment. Plus 2 times x plus 2. Yeah, I think I did this today in class, but let's do it again. So you can't do anything with that negative 4x, so I'm just going to write that down. But you can distribute this negative 2. Remember, it's a negative 2. It's not just a positive 2. So the whole entire negative has to be distributed through here as well. So that's going to give you negative 6x minus 10. And this is going to be negative 6x. Now I have to take this 2 and distribute it through this parentheses. It's a positive, right? So I can just keep it plus 2x, and then positive 2 times positive 2 is positive 4. Add like terms, negative 4x minus 6x is negative 10x. Minus 10, you just bring that down. Right here, negative 6x plus 2x is negative 4x, and then plus 4. Let's get the x's on the same side. So again, just like we did today in class, I'm going to take the negative 10x and move it over here to the right-hand side. I'm going to do that by adding a 10x because they'll cancel out that way. I'm going to add a 10x to this side. Since the x is on the right-hand side, I'm going to take this positive 4, put it on the left-hand side. So I'm going to subtract a 4, I'm going to subtract a 4. All right? These two canceled out. This is going to be a negative 14, and this is going to be a 6x, and that cancels out. Divide both sides by 6. Again, don't leave this fraction the way it is. You have to reduce the fraction. So that cancels. So x equals, what goes into both of these? 2 does. 2 goes into 6 3 times. Let's put it down here. 2 goes into 14 7 times, and there it is, negative 7. Don't forget that negative. It's negative 7 over 3. So negative 7 over 3. All right, that was a repeat, but that was free of charge. All right, number 13. So it is, get my paper straight here. Number 13. It's 9.8 minus 15x equals negative 15.7. We may use a calculator on this, but we're not going to use it to the very, very end. All right, the way that that I taught you when we first did these things is you can take these decimals. It's kind of like the fraction. We're going to get rid of the fraction, but in this case, we're going to get rid of the decimal. How many places am I going to have to move this to get it into a whole number? Well, I just have to move it once to the right. This is already a whole number, so I don't have to worry about that too much. Then over here, I have to also move that one place to the right. So moving a decimal one place to the right means what? What are you doing when you move a decimal to the right? It means you're multiplying by 10. So what I'm going to do is multiply this by 10, and then I got to do everything. Remember, if I do something to one side, I got to do that to everything on that side. So multiply that by 10, and we're going to multiply this by 10. All right? Multiplying by 10 is easy when you have a decimal. It just means you move the decimal to the right one place. So if I move that to the right, that's 98. That's what 9.8 times 10 is. It's 98. Okay? Right here, now this decimal is already all the way to the right, so if I multiply that by 10, I just stick a 0 on there. So that's minus 150x. And this is going to be times 10, so again, I move the decimal to the right one place, that's multiplying by 10, and that gives me a negative 157. All right? Now I'm going to subtract a 98 from both sides. The rest is pretty straightforward now. Since everything's whole numbers, I don't have to worry about any decimals. So that cancels out. Negative 157 minus 98, what's that? 255, negative 255. And bring this down, that's a negative 150. Don't forget the negative, all right? That's the sign of this number. Even though some people say, oh, I thought it was subtraction. Well, subtraction and negative are really the same thing, so I just bring that down. Now I got to get x by itself, so I divide by negative 150. So come over here, come over here. Now what I would do, this doesn't come out nice and even, so I would put this in a calculator. This is a situation where I would use the calculator. So you put it in a calculator, you get 1.7 positive, because negative divided by negative is positive. 255 divided by 150 on the calculator. I couldn't do that in my head. So I stick it in a calculator, and you get 1.7. And it's exactly 1.7. It's not an approximation. All right, I hope that helps. Let's do 14. 14 is kind of the same thing. Again, let me rearrange my papers. Let's just scooch this up so we have a clean slate. 14. Oops, there goes my pen again. I keep pushing that button. All right, 14. So it's 0.09x, 0.09x plus 0.14 times, parentheses, 10,000. 10,000 minus x, parentheses, equals 1275. All right, here we go. Just like the same one, or just like the other one, this is the same. where in order to make this a whole number, and it's just a lot easier to work with whole numbers than it is decimals. That's the only reason that we're doing this. It just makes it a little simpler, a little bit easier to work with if you got whole numbers. So let's do it. What am I going to have to do? I'm going to have to move this 2 decimal places, 2 places to the right. So what am I doing? That's not multiplying by 10. What's 2 decimal places? That's 100. So I'm going to have to multiply this by 100, and I'm going to also multiply this by 100 and this by 100. All right, put little dots there. I'll just put this over top. But that means 100 times all this. Again, it's easy to multiply decimals by hundreds or any power of 10 because all you have to do is just move the decimal place. So if I multiply by 100, I'm moving it 2 places to the right. That just gives me a 9x. It's a lot easier to deal with than 0.09x. It's worth the little hassle of multiplying by 100. And then this right here is easy too. Watch what I'm doing. I'm only multiplying that 0.14 times 100, so I get a 14. I went through an explanation the other day about why you don't also multiply this stuff by 100. I'm not going to do that right now, but you can always go back and look at that explanation. So I just keep that the same. And then right here, 1275 times 100, I just put 1275, stick a couple zeros at the end of it, I'm good to go. Now you work this like you would work anything, any algebra problem. So I'm going to get 14 times, what's that, 10,000? So 14, how many zeros I got there? 4. So I'm going to go 1, 2, 3, 4 minus 14x equals, I didn't do anything to that side, 1275, couple zeros, here we go. And now you just do some math. 9x minus 14x, what's that, 5? Negative 5x. Then I'm going to subtract, what is that, 140,000? And so I'm going to subtract 140,000 from this as well. I'm not going to show it here. You know it's going to cancel out. All right, equals 1275. It's 12,500. 12,500. When you do that subtraction right there, it's negative, by the way. Sorry, it's negative because 140,000 is bigger than 127,500. So you take the sign of the larger number, it's negative. Now you divide by negative 5, divide by negative 5, and it actually comes out nice and even. It comes out to 2,500, 2,500. That's how you get that. Now the numbers were a little big. Sometimes it's a little awkward when the numbers are really big or you got decimals, but we made it a little easier on ourselves by getting rid of those decimals, by multiplying everything by 100. All right, we're moving right along. 15. Let me see what 15. Did we do that today? Yeah, we did those. I'm not going to do those. 15 and 16, we did those today. Or at least we did 16. If you can do 16, you can definitely do 15. So let's move on because I need to go. And you don't want this to be that long anyway. Let's do 17. I don't think we did this in class today. So it says solve for x. Or here, I'll write it exactly the way we wrote it on the test. Solve y equals mx plus b. That little formula right there should be familiar to you. We're going to talk about that a lot later on in this book. But all we're trying to do now is just get x by itself. We're just trying to get x by itself. And you're like, how in the world can I do math with this? There's all letters. There's no numbers here. But these these letters represent numbers. So all the stuff you can do with regular numbers, you can do with these letters. So if I want to get x by itself, what's going on with this x? What are these other numbers, letters? What are they doing to the x? Well, this m right here is being multiplied by the x, and this b is being added to the x. So the first thing we're going to get rid of is the b. So let's subtract b from both sides. If I subtract a b from this side, you know it's going to cancel out. So how do I show this minus b? Well, I just put y minus b. That's actually easier than, it's somewhat easier anyway, than if you had like regular numbers. You don't even have to do any arithmetic. You just put y minus b. That's it. Now what are you left with? You're left with m times x. You want to get x by itself? How do you get rid of the m? It's being multiplied. You do the opposite, divide. If you divide by m, you know the m's going to cancel. So what do you do to this side over here? You also divide by m. There it is. And now you have x by itself. And that's your answer. If you want to put x first, x equals all this, feel free. I'll just do it like this for the sake of time. All right, number 18. This might be the easiest out of all four of these, 17, 18, 19, 20. This might be the easiest one out of them all. And a lot of you guys got this right, so that was good. All right, so we are trying to solve this. It says solve this for, what are we solving for? Capital B. So we're solving for capital B. That's what we're trying to get by itself. All right, now this one you actually do have a number, but you want to get rid of that 1/3 because that's with the B. You want to get rid of the H because that's with the B. A lot of people might look at this, and some of you guys on the test did this. You looked at the 1/3 and you said, oh, let's divide by 1/3. I mean, technically, yeah, you could do that, but then you're going to have to change it over here. It's a whole thing. So what I'm going to do is to get rid of the 1/3, I'm going to multiply it by 3/1. Right? That's how you can get rid of a fraction. Multiply by its reciprocal. Reciprocal means you just flip the fraction. Why did I do that? Well, I did that because the 3 and the 3 will cancel out. That's the whole reason that I did that. And I got rid of it. But if I multiply the right side by 3, I also have to multiply the left side by 3. So this right here just canceled out. So now I just have BH. And I'm trying to solve for B, so I need to get rid of the H. What is that H doing to the B? It's being multiplied. How do we get rid of something that's being multiplied? We divide. So I divide both sides by H. You know the H is going to cancel out. You come over here, divide this by H. That's basically your answer. Let's write it real nice and neat. So B equals 3V over H. And that got B by itself. All right. Let's do 19. And I think that's the last one because we did 20 in class. I think we did 19 in class too. I don't know. I did it for a couple people today, so I can't remember if I actually did that on the video or I just did it with other people. We'll do it. All right, so here we go. We want to solve for F. Solve for F. Solve for capital F. This is Celsius Fahrenheit equation, right? We did one like this in class. I don't know if it's the exact one or it was the Fahrenheit one. It might have been F equals, and then all this stuff, and you had to solve for C. But now we're going to solve for F, for Fahrenheit, the temperature in Fahrenheit. So first thing we're going to do is get rid of this fraction that's multiplying by this parentheses. So how do I get rid of that fraction? Well, this is a little different, but it's similar to what we just did up here. It was 1/3. What do we do to get rid of a fraction? We multiply by the reciprocal, right? On this one, we're going to do really the same exact thing. We're going to multiply by the reciprocal. What's the reciprocal of 5/9? Well, you just flip the fraction. So what is it? It's 9/5. That way, the 9's cancel and the 5's cancel. That's the whole reason for multiplying by 9/5, is so that they cancel out. Well, whatever you do to one side, you got to do to the other side. So we're going to put 9/5 over here. Let's write it a little bit nicer. 9/5 C equals, remember, this canceled out right there. What are we left with? F minus 32. Now it should be really simple. What are we trying to solve for? F. I'm going to get that by itself. What's with it? What's this doing to it? You're subtracting a 32 from it. So how do I get rid of it? I add a 32. It's going to cancel out. Now how do I show plus 32 here? Well, this is what I do. I put 9/5 C plus 32. And that's equal to F. I'll put the F right here. And that's how you do it. All right, some people wrote this, 9C over 5. That right there and this right here are exactly the same thing. 9/5 times C is the same thing as 9C over 5, right? Don't do this. Don't do 9C plus 32 all over 5. This and this right here, this whole thing right here and this right here are not the same thing. This is incorrect. I'm not going to go through the reasoning why right now. That's another topic for another day. All right, but you can't do it. So that's how you do that problem. Okay, so we are taking the test tomorrow. Tomorrow is November 2nd, 2023. All right, we're taking the test tomorrow. It's not going to be the exact problems, but they will be very similar. Very similar to the ones on the test and the ones that we've gone over in the last 2 videos, okay? So that's what I would do. And I'll tell you right now, I'll give you a little hint. I didn't just make these questions up, all right? Now, I had to make up a brand new test, all right? And I graded the old one. I'm going to have to grade a new one. So I'm doing a lot of extra work for you guys to retake this test. And this is not something that I'm going to do all the time, if ever, all right? Maybe once a semester. Maybe this will be the last time until maybe third or fourth marking period, depending on how you guys do on the test. So this is very rare that I ever let anybody retake a test. So just keep that in mind. Don't expect this every time you do poorly on a test. So we got to study the first time the rest of the year. You got to study the first time and not wait until you do poorly and then I do a retake. It's not gonna happen. All right. Anyway, enough of that. I get the problems from the book. So the test problems are basically equal to the test problems. All right, that's where I get the problems that I put on the test. I literally have the book open and I'm looking at problems that I think, and every problem's slightly different. None of them are like exactly the same. Sometimes they have the same principles, but they're not exactly the same. But the test, what did I put? Test problems equals test problems. That was dumb. Anybody catch that? Test problem equals homework problems. All right. My goodness. All right. So the test problem equals the homework problems. So I get the problems that are going to go on the test from the homework. Every single problem on the test is from the homework. All right. So anyway, I don't know if that helps you or doesn't help you. Good luck, though, tomorrow on the retest, and I hope you do much, much better. Thanks.